Alright, so now I want to take a look at 7.1 exponential functions in their graphs. Just going to go through an overview with you through the section. So exponential functions come in this form: f of x. Some books may use b for the base. This book uses a, and your exponent is a variable, or your variable is the exponent. So you have a few restrictions that they highlight for an exponential function. Your base, this bottom number, the big number, has to be greater than 0, so it has to be positive, and it cannot equal 1. 1 would just be a linear function. It talks about why it can't be negative, and it gives you this example. So if it was -1 and you raise it to the half power, it's kind of like saying the square root of -1. We know we can't take the square root of a negative number. That will be imaginary, so that's why they say it's not real. So they got some other terms here that you can look at. Here they are showing us two examples. One where we have a positive number that is less than 1, and then we have another that gives us a positive number that's greater than 1. Those are the two scenarios that you'll see. This one will lead to exponential decay, something that is less than 1 but between 1 and 0, and this is more than 1. So that will be growth. What you will notice as this x value is getting bigger, is increasing these numbers, the y value is decreasing. So this is decay. And then here, as these x values are getting bigger, so is the y value getting bigger. This is growth. Here is the visual for decay from left to right. This graph is decreasing, going towards 0. And for growth, this graph is increasing, going from left to right. Down here, they discuss the end behavior. So again, it's kind of showing decreasing function. Your base a will be between 0 and 1. And then it says as the y value goes toward positive infinity, the y value goes toward positive infinity as x goes toward negative infinity, and the y value goes to 0 as x goes to infinity. And then for the increasing function, we have the base is going to be bigger than 1, and y goes to 0 as x goes to negative infinity, and y goes to infinity as x goes to negative infinity. So just kind of describing the end behavior that we see here. So alright, here they go through a few examples, which I will show you how to work these by hand. You can graph them with the calculator, but I'll show you how to do them by hand and get a visual. And then we'll also solve a few. So when we begin to solve, we will be trying to get the same base. So you'll start with something of this form, and we'll try to rewrite them so that both these numbers are the same base, and we just solve for the exponent, the x equals b part. So once the base is the same, we can drop the bases and just focus on the exponent part and solve that. So it kind of gives you a step-by-step of how to solve that. And then there's a few examples here that they kind of go through. And again, we'll do our own. But just to walk you through one, you have this 25 to the x power minus 125. Both 25 and 125 can be written as base 5. So they do that. And then once they have the same base, they just focus on the exponent. So 2x equals 3. And then they solve for x and they get 3 over 2. So we'll be doing a few like that. Alright, so here's some directions for inputting in graphing exponential functions. So again, you can graph them and get the graph to see what they look like. You can also solve them, but I want to show you how to do it here by hand.